Class 10 children, today again we will learn chapter 16 trigonometrical identities and tables, page 1611, question number 13. Show that root over 1 minus cos A by 1 plus cos A equal to sin A by 1 plus cos A. As you all know, we have to prove LHS is equal to RHS. So let us start. LHS equal to the same thing I write, root over 1 minus cos A by 1 plus cos A. As I have told in my last video also, that in this chapter you try to make all the trigonometrical identities either in sine or cos. So in this question you can see the identity is already in cos. So now we cannot change cos, let it be cos only. But now what to be done that we get this answer? Now here what I thought, I can see here in the right hand side 1 plus cos A is in the denominator. And here also in the left hand side we have 1 plus cos A. But here there is no root over, and here but we have root over. Now what I thought is that if I will bring one more 1 plus cos A here, it will become whole square. And whole square is square and this root over will vanish. Then we will have 1 plus cos A. So based on that knowledge, what I did, same thing I wrote here, and I multiplied the same coefficient, the same ratio with 1 plus cos A by 1 plus cos A. Now by doing this, what happened? Same identity, if you cancel, it is 1. It is 1 actually. But this is the technique of writing, and anything multiplied with 1 is same. So my conclusion also is same, but with some technique. So now by doing this multiplication, what is the benefit? Now you see 1 plus cos A, 1 plus cos A. If multiplied 2 times, it is 1 plus cos A whole square, because in algebra any coefficient, any variable multiplied 2 times is whole square. So same thing, whole square. Now 1 minus cos A, 1 plus cos A is a algebraic formula which is A minus B, A plus B, which is a formula of A square minus B square. Now who is A? 1, A square, minus who is B? Cos A whole square. That is A square minus B square is the formula. Now what happened in the next step, you can see here 1 square is 1 minus cos A whole square is cos square A. Square will come and be here. So cos square A. Now next thing, you can see here I wrote same 1 plus cos A whole square. But in the next step, you can see root over is only at the top, not at the base. Because this square and this root over will cancel, and only it will be 1 plus cos A. That means the denominator has lost root over, but numerator did not. Because you might be saying, sir, there is square here also. Why it did not vanish the root over on the top? Let me tell you, it is a whole square, but the square is only at the cos A. 1 has lost its square, and whenever there is minus at the middle and only square is in the one part, then root over will not vanish. It should be as a whole square. One more thing I want to say you, had there been no 1 and minus, only there would be cos square A, then this square and this root over also will vanish. But in this case you cannot. Now you can see root over 1 minus cos square A is a formula of sin A. I will show you the formula list. Here you see sin theta is root over 1 minus cos square theta. But here since we have A, so therefore here also we will have A. Same formula has come here from here to here. And now you can see RHS also is same. That means my LHS and my RHS is same. I can say LHS equal to RHS proved. Number 14. This is your left hand side, this is your right hand side. We need to prove LHS equal to RHS. So same thing of left hand side I wrote here in the LHS. Now I have always told you, try to target to convert the identity either in sine or cos. So already it is in sine and cos. Don't target these two identity, but target tan and cot. And tan becomes sine by cos. So our target is coming here, tan became sine by cos, and it is a part of formula, and cot became cos theta by sine theta. Now this formula we have discussed, you can see here, this is the formula list. Tan is this and tan is this and cot is this. Same thing I did here. Now same thing I wrote here. Now I did the LCM. LCM is cos theta sin theta, and the upper part what happens, cos you cover, sin remains. Sin into sin is sin square theta. Sin you cover. Now cos into cos is cos square theta. Now what happened, same thing I wrote here. Now sin square theta plus cos square theta is 1. This formula also we have discussed in the last video. Sin square theta plus cos square theta is 1. So 1 by cos theta sin theta. Now sin theta plus cos theta will multiply with 1. Same thing will come, and cos theta sin theta will come at the base. Please remember, there is plus and here it is multiplication. So you cannot cancel this way that both are same. No, they are not same, because there is plus and here it is multiplication. Now what I did, I separated this plus at the middle, and sin theta, I wrote this denominator here, sin theta by cos theta into sin theta plus cos theta by cos theta into sin theta. That means what I am doing, normally from here we do LCM and we reach here, but this time I am breaking this plus into two parts and giving the denominator to both the identity separately. And by doing this, what happens, sin got cancelled, and here at the top 1 remains. 1 by cos theta remains here, cos got cancelled, and here 1 by sin theta remained. Now 1 by cos theta is sec theta and 1 by sin theta is cosec theta. Now I will show you this reciprocal formula. I had told you 1 by sin theta is cosec theta and 1 by cos theta is sec theta. Same thing here. 1 by cos is sec theta and 1 by sin is cosec theta. And same thing we have in RHS also. You can see here RHS is same. So RHS equal to same thing, LHS equal to RHS proof. Let me discuss one more question, children. This is your LHS and this is your RHS. So let us try to prove it. Here you need correction in the question. In the book, in your book it is cos theta, but you write it cot theta. That is mistake, printing mistake. Make it cot theta. So I wrote the LHS. Now as you all know, we should target to make all the identity either in sin or cos. So sin is same, sin only, but you write cot as cos theta by sin theta, which is a formula. And cos theta you write same, and 1 minus tan theta you write sin theta by cos theta. Now lower part you do LCM. Here LCM will be sin theta, and sin theta will multiply with 1, sin theta minus cos theta. Same thing here, cos theta will be LCM and you will get cos theta minus sin theta. At the top it is same, numerator is same. Now from this part, now I can say when there is double fraction, one fraction can become multiplication. So sin theta into, and this will change. Sin theta will go up, sin theta minus cos theta will come down. Same thing here, plus cos theta into cos theta will go up, cos theta minus sin theta will come down. Now sin into sin will be sin square theta. You cannot cancel this sin. Why? Because there is minus in the middle. So sin square will multiply with sin sin square theta by same sin theta minus cos theta. Here cos square theta multiplication and then by cos theta minus sin theta. So after reaching to this portion, you can see that this lower part, the denominator of this portion and this portion is almost same. But what happened? Sin theta here is in the first position, cos in the second, and here cos is in the first, sin is in the second. Had it been plus plus, then meaning would be same, but because of minus, the meaning is not same. So what I targeted here is that I will make this denominator also same like the first one. So sin theta minus cos theta, to make here also sin theta minus cos theta, I took minus common from here. If I take minus common from here, then what will happen? Minus will become plus and plus will become minus. So you can see minus sin has become here plus and plus cos has become minus, and the minus is common here. Now in the next step what happened? You can see our denominator has become same now, but this minus will multiply with this plus, and plus into minus has become now minus. So there is no more plus, it is now minus, and this minus has come to the middle. But one good thing is that now denominator is same. When denominator is same, LCM also will be same. So same LCM came here, and when LCM is same, then upper part also will be same. So here we have sin square theta minus cos square theta. Again telling you that plus became now minus because this minus got multiplied. Now don't say that sin square theta minus cos square theta is 1. No. Actually sin square theta plus cos theta is 1. There should be plus. But here we have minus. So here what we will do, we will apply a formula of a plus b into a minus b. A plus b into a minus b means here sin theta plus cos theta, sin theta minus cos theta. And lower part denominator is same. Now both of them got cancelled. Our answer is sin theta plus cos theta. But our RHS is cos theta plus sin theta. But when there is plus, meaning is same. I can change also sin theta plus cos theta. Now LHS equal to RHS proved. So this way you do some of the questions given by me as homework. Thank you children.